Welcome to today's video on normality. In the biochemical calculations playlist, we have been seeing about the different ways in which concentration of a solution may be expressed. We have seen about percent solutions and molarity and molality. Now we'll proceed with normality. Normality may be defined as the number of equivalents per liter of the solution. Normality is denoted by the capital letter N. If we have one equivalent in 1 liter, it is a one normal solution. So what is an equivalent? Equivalent is equal to weight expressed in grams divided by the equivalent weight. Equivalent will be 1 when the weight in grams corresponds to the equivalent weight. Okay, when these two terms, the numerator and denominator are same. So when we express the equivalent weight in grams, it can correspond to 1 equivalent. In the case of moles, we saw it is weight in grams by molecular weight. Molecular weight can be easily determined from the molecular formula, and it is better if we see it in the label of the chemical bottle because it gives the molecular weight including the water of crystallization. But how do we find out the equivalent weight? For an acid or base, equivalent weight will be molecular weight by N, where N is the number of replaceable H or OH minus ions. So in the case of HCl and NaOH, N is 1. So in such a case, equivalent weight will be equal to the molecular weight. And since these two are equal, molarity will be equal to normality. Whereas if you take the case of sulfuric acid and calcium hydroxide where we have two replaceable H and OH, N is equal to 2 in this case, equivalent weight will be equal to molecular weight divided by 2. This is for acids or bases. For phosphoric acid H3PO4, it will be equivalent weight will be molecular weight divided by 3. For an oxidizing or a reducing agent, equivalent weight will be equal to molecular weight by number of electrons lost or gained in the reaction. So if we take the case of potassium dichromate, which acts as an oxidizing agent, when we see the ionic formula for the redox reaction, we see 6 electrons are involved. Therefore, equivalent weight will be molecular weight by 6. Molecular weight is 294. So, the equivalent weight of potassium dichromate is 49. For a salt, it will be molecular weight by number of metal atoms into valency of the metal. So if you take the case of aluminium sulfate, the molecular weight is 340. We have 2 atoms of aluminium and the valency of aluminium is 3. So 2 into 3. So 340 divided by 6, it is 56.6. When we see the relationship between normality and molarity, we can use this formula. Normality will be equal to molarity into molar mass by equivalent mass. So, molecular weight by equivalent weight. In the case of an acid or a base, it can be further simplified and written like this because we have already seen in an acid or a base, equivalent weight will be molecular weight by N. N can also be called as acidity or basicity, the number of H plus or OH minus ions it can give in solution. So, molecular weight by equivalent weight will be N. So, instead of this term, we are substituting small n here. So, for an acid or base, we can simplify and write the relationship between normality and molarity as N is equal to N into M. For HCl or NaOH, this N is 1, so normality will be the same as molarity. For sulfuric acid, normality will be twice the molarity. So, a 1 molar solution will be a 2 normal solution. We will move on to the problems. How many grams of solid sodium hydroxide are required to prepare 500 ml 0.5 normal solution? So, we are using the same formula that we adopted for molarity and molality. So 1000 ml of a 1 normal solution will contain 1 equivalent. As we did for molarity, instead of 1 equivalent, we can write the gram equivalent weight itself. Instead of 1 mole, we wrote the gram molecular weight. So instead of 1 equivalent, we can substitute the gram equivalent weight. This makes the calculation simpler. So now 500 ml of a zero point 0.5 normal solution. So how much should we weigh? So the cross multiplication pattern we have seen is like this. So x will be equal to 500 into 0.5 into 40 divided by 1000 into 1, which is 10 grams. Next problem. How many grams of solid sodium carbonate is required to prepare 500 ml of a 0.1 N solution? Now we have to see what is the equivalent weight. If you see the molecular weight of sodium carbonate, it is 106 because 2 into 23 sodium 46, 1 carbon into 12, 12 and 3 oxygen 16 into 3, 48. If you total, it is 106. And we have already seen it is the number of metal atoms into the valency of the metal. So number of metal atoms is 2 and valency of sodium is 1. So 2 into 1. So the equivalent weight is 53. So for 1000 ml of a 1 normal solution will correspond to 1 equivalent, which is the gram equivalent weight, 53 grams. We need 500 ml of a 0.1 N solution. So x will be equal to 500 into 0.1 into 53 divided by 1000 into 1, which is 2.65 grams. As we have already seen, we can not only find out how much we have to weigh to prepare a particular normal solution, we can also find out the normality, or we can even find out in how much volume we have to dissolve. So we will see one problem for how to find out the normality of a solution. So what is the normality of a solution containing 3.15 grams hydrated oxalic acid and 500 ml of the solution? Molecular weight of oxalic acid is given 126. Just for us to understand how to include the water of crystallization, we can see C2H2O4, 2 into 12, 24, 2 carbon atoms, 2 hydrogen atoms, 2 into 1, 2, 4 oxygen atoms, 4 into 16, 64. So it looks like the molecular weight is 90. But there are two molecules of water involved in the crystallization. So it's mentioned here as hydrated oxalic acid. So 18 into 2, 36. So totally the molecular weight is 126. When we see the label of the chemical, we'll be able to see the molecular weight as 126. And now we know that we have two replaceable H here. So the equivalent weight will be 126 by 2, which is 63. So 1000 ml, 1 normal, we are putting it as 63 grams. So 500 ml, what is the normality? If you have 3.15 grams, same method of cross multiplication. So x will be 1000 into 1 into 3.15 divided by 500 into 63, which is 0.1 N. So we have now seen how the normality of a solution can be calculated, or how much we have to weigh to prepare a particular normal solution.